Okay, good afternoon, guys. Before I continue, please subscribe and then follow for more updates on operation research and other questions that bothers us every day and then in our lifetime. So today we are going to look at operation research, and we are going to look at how to use the linear programming method to solve questions. And as you know, linear programming method can be used to solve problems in our companies, in our offices, in our day-to-day activities, and so on and so forth. So I'm going to give you an example, and I'm going to teach you how to use the linear programming method, which is by the graphical method, to solve such questions or problems. So today the question that we have over here is Farmo Ghana Limited produces Fan Yugo and Fan Chuku. Some Ghanaians love this. I don't know about you. The two key resources used by the company are milk and skilled labor. Given the limited resources, the company desires to know how many sachets of Fan Yugo and Fan Chuku to produce each day in order to maximize profit. There are 40 gallons of labor and 120 gallons of milk available each day for production. Fan Yugo requires 1 hour of labor time and Fan Chuku requires 2 hours. Also, Fan Yugo requires 2 gallons of milk while Fan Chuku requires 3 gallons of that. The profit from a sachet of Fan Yugo is 40 Ghana cedis per unit. From Fan Chuku is 50 Ghana cedis per unit. Formulate a linear programming model for this product mix problem and solve using the graphical analysis. Okay, so when you get this type of question, you should come out with a table. The first step that you should do is what? Come out with a table, and then you will take it from there. So this is my table that I've come out with. The first one is product, and from the question, the product that we have is Fan Yugo and then Fan Chuku. And then the labor, that is the hours of labor that used for Fan Yugo is 1 hour, and then Fan Chuku is 2 hours. Then the gallons used for Fan Yugo, we have 4 gallons for Fan Yugo and then 3 gallons for Fan Chuku. The resources available from the question, we have the resources available, we have 40 hours of labor and then 120 hours of milk. So those are the resources available. And the profit from the question also, we have 40 Ghana cedis per unit for Fan Yugo and then 50 Ghana cedis per unit for Fan Chuku. Okay, so this is the table that we've come out with. Right now we are going to look at how to use the graphical method to solve such problem. So what we must do for the first time is what? To get a constraint. So this is the constraint. The constraint x1 and then x2, that is what we are going to use. So the labor constraint is what we from the table is sort of represented over here, which must be less or equal to 0. And then the mole constraint, which must be less or equal to 0. And we have the non-negativity constraint. You should take this very, very carefully. You should take a very good look at this. That is the non-negativity constraint, which is x1 and then x2 should not be equal or greater. Should be equal or greater than 0. Okay, so the objective factor is what? To maximize profit and then to minimize cost. That is why we are using this approach, the graphical method approach. Okay, so we are going to continue with the graphical method.